today what I want to look at is a little more closely look at transforming these sine and cosine curves. Okay? And basically when we sketch these curves, we're going to sketch where the first period would go. Alright? You guys we saw yesterday that first 0 to 2 pi, that's the first period. When you make your sketches, I want those 5 points for the first period, and you don't need to sketch any more than just that one period, but you'll shift it or whatnot the way it's supposed to go. Now let's just see here, first of all, how this moves about, okay? The only real change in this compared to what we have done with our functions before and our transformations is this bx minus c. And it's really the horizontal translation. Okay? Remember how before we used h and k? We had f, here we go, f of x minus h plus k, and hk would be the horizontal shift, okay? You can see right here, however, we have a c over b. That's where our left endpoint is going to be. In other words, that endpoint was at the origin normally, like with sine, but now it's going to get shifted to whatever c divided by b equals, okay? Now, another way of writing this would be d plus sine of b parentheses x minus c over b, okay? In fact, if you look at some books, they'll actually do it with the b outside of the parentheses, and then what they'll actually have is k plus a times the sine of b x minus h, okay? Now your book uses this, so that's why I'm showing that to you, but this is also a valid way of writing it. K plus a times the sine of b times x minus h, and h would then be that horizontal shift, okay? But h is the same thing as c over b. Alright, so your horizontal shift, and actually your complete translation is your origin is going to shift to wherever c over b and d are, okay? So whatever c over b and d are. Now, notice it still is a minus c, so you still take the opposite of what you see in the parentheses there for the horizontal shift. So that hasn't changed, okay? But we shift our origin over there, and then all the rest of the points have to shift there as well, okay? Now, stretching and shrinking. Stretching vertically, that was a, okay? Your amplitude for sine and cosine is going to be a. Okay? So there's our amplitude, a. It's stretched or shrunken horizontally with b. That's what the x is multiplied by, and that's what we've seen already. That horizontal stretch or shrink is going to impact the period, and the period, you can see right here, the new period, if it's changed, is 2 pi divided by b, okay? Alright, the period equals 2 pi divided by b. And since we're dividing by b, there's an inverse relationship. So if b is a larger number, that means our period is going to get smaller. Okay? If b is a fraction or smaller number, that means it's going to be getting bigger. Yes?
If you were to use one of the other equation you showed us, the k plus whatever, and then you have b times x minus h,
Mm-hmm.
if you change b into b times x minus h, wouldn't it also change c?
Well, that's the thing. You wouldn't have a c in that other form.
No, but like, I mean, so if you change b in this one, it's only affecting the x, but if you change b in the other one, the b times h is going to be different than what the c is.
Well, yes, if you were writing it out like this, c would look a little different, but the fact of the matter is you're still going to do c divided by b, so you'll end up with the same value for your shift. Okay? If you use that. These are equivalent as long as you use the same conversions that were given here. Okay? You can either use the normal HK if you use this form. You can use C over B and D for this form.
But what I'm saying, like, if b started out as 1 and then you changed it to 3, wouldn't 1 be 3x minus 3h? Oh wait, but 3h is c.
Yeah, 3H would be C. Okay.
So c never changes in the second one? Like, how do you know what c would be if you change b? I don't know, maybe.
We don't really, C doesn't really do anything for our graph specifically. C is just part of this horizontal shift.
Okay.
So if you change B, it's going to change what the horizontal shift is.
Okay.
So.
Never mind.
Alright. Now, reflections. Reflections work the same way as our old functions did. If we're reflecting across the y-axis, that means that we multiplied the x by a negative. Okay? If we're reflecting across the x-axis, a vertical reflection, that means the negative is on the outside. And just a reminder here, make sure you don't ever say that the amplitude is negative. Okay? If you see a -2 sign, the amplitude is 2, and there's also a reflection. That negative and the 2 do two different things. Okay? Now, I want to show you here something. If we were going to graph using our calculator, and for sake of time, I'm not going to have all of you do this on your own calculators, but you can try this. One thing that you need to be careful about if you're graphing on your calculator is the mode. Make sure that your mode, or make sure you at least know what your mode is set to. By default, it's going to be radians, okay? Now, when you're dealing with this, you can use the pi button to help you set your window. When you go to Windows settings and you have your X min and your X max, you can do -2 pi and +2 pi. And your calculator will see that and it'll adjust the window. Okay? Also be careful with your vertical window, because especially if it's been shrunken at all vertically, it could be really hard to see. So adjust your vertical window. Here I did 3 different ones. Okay? Here in red is the original y equals sine of x. Okay? What is this one going to do? 3 sine of x. It's a vertical stretch, and you can see that this is the blue one right here. Instead of going up to just 1, it goes up to 3. And instead of going down to -1, it goes down to -3. However, notice this. See that? The point where it hits the x-axis is actually the same as our original sine function, because nothing has been done to this to adjust it at all horizontally. Okay? Now, this third one, however, what's happened to that?
Horizontal shrink.
horizontally shrunk. So now the period equals what?
Period 1/3.
1/3 of 2 pi.
1/3 of 2 pi, yeah, so 2 pi over 3. And if you look at the green one here, here it's completed an entire period in 2 pi over 3. Okay? Now, again, notice, if I were graphing this, this is what I would do. I would say, okay, I'm still starting at the origin. My period is 2 pi over 3, so I would put this point here. Okay, so I put my starting point, my end point. The middle point is also going to be on the x-axis with sine, right? So halfway between 0 and 2 pi over 3 is 1 pi over 3. Okay? Then, if I'm trying to find my max point, I'm going to find halfway between 0 and pi over 3. So what's that? Pi over 6. Okay? And then I know I'm up at the highest point. So look, my amplitude's 1, so my highest point's up here at 1. And then I also look here, what's halfway between pi over 3 and 2 pi over 3?
Pi over 4.
4 pi over 6?
Well, that is pi over 3. What is it? Pi over
3
4?
pi over 6.
That's pi over 2.
It's pi over 2.
Which one?
3 pi over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2. So that's going to be where my lowest point is. And then I can sketch my curve. Alright? That make sense? Okay, good. So let's try a couple of these. Let's try a couple. Here we have one, 3 times sine of 1/2 x. What I'd recommend doing is writing this down every time. What's my amplitude? What's the period? What's my translation? Okay? So what is the amplitude?
3.
3. What's the period? What?
4 pi.
4 pi, okay? 4 pi. It's 2 pi. The period is 2 pi divided by 1/2. So you flip and multiply and it's 4 pi. Okay? What's the translation?
Vertical stretch by a factor of 3 and a horizontal stretch by a factor of 2.
The translation, shifting.
Something, comma 3. C.
2
There's
pi,
no
2 comma 3.
What?
1/2 comma.
There is none. Do I see anything being added or subtracted in there?
No.
Nope. So there's no translation. Okay? Alright? So, if there's no translation, where is this graph going to start?
0, 0.
At 0, 0. Now, my period is 4 pi. Okay, and I'm going to get 5 points. So I have a bunch of hash marks on here, but I'm going to do, here's 1, 2, 3, 4. My 5th point here is going to be the end point. Where is that?
4 pi.
It's at 4 pi, and it's 4 pi what? Where does sine end?
1.
1, 0, negative 1? Where does sine end?
Positive 1.
So what? Yeah, 0.
At 0. Remember? When we get back around the whole circle, we're back where we started, right? So we got to end the same as where we began. Okay? Now I'm going to find my middle, all right? In the middle, where are we as far as the y-coordinate? At 0, okay? We're at 0 again. With sine, the first, middle, and last points are all on that middle line, okay? Which is the x-axis, unless we've shifted it up or down. So what value of x is that?
2 pi.
2 pi. Okay? Now, what's halfway between 0 and 2 pi?
Pi.
pi. Where am I there?
3.
I'm at 3 because my amplitude is 3. So I put the point up there, and then I need my fourth point here. Halfway between 2 pi and 4 pi is 3 pi, and where am I there? I'm at -3, -1, -2, -3, okay? And I've got my 5 points. I can now draw my curve. And that's exactly what I want to see every time I ask you to sketch the curve, sketch a sine curve or a cosine curve, okay?
Is cosine graph the same or just with different numbers?
If this were cosine, the amplitude and period and translation all behave the same way, except if this were cosine, okay, y equals 3 cosine 1/2 x. Cosine starts and ends where?
1 and 0.
Up at 1. These have to start and end at the same spot. So since my amplitude is 3, since cosine starts and ends at the top, I'm going to start and end up at the top at 3. Where am I in the middle?
0.
No,
Negative.
we're at the bottom, okay, at -3. And then for cosine, at these 2 points are the zeros. At, okay? So, this is where you really got to make sure you're familiar with the original sine and cosine curves so that you can then adjust it to this, okay? Alright, any questions here? Okay. Let's do one more. We're not going to get to the actual model today. That's okay. We'll get to that tomorrow. But let's look at this, okay? Alright. This is a fun one. Here we have 4 plus 2 times cosine of 1/3 x minus pi over 6. It's a lot to this one. Okay?
Is it fun, right?
Yeah. Alright, so what's our amplitude?
2.
2. Alright? What's the period going to be?
Pi. 6 pi.
1
Third.
over 2
Wait.
pi.
What,
6 pi.
how do we get 6 pi?
Times
2 pi divided by 1/3. Okay? You flip and multiply and you get 6 pi. Okay? Everyone with me on that?
Mhm.
Okay? Now the translation. Remember your horizontal translation is that C over B. So what's C?
Pi over 6.
It's pi over 6 over
1/3.
1/3. What does that come out to?
Pi over 2.
That's pi over 2. Okay? So our translation is going to be pi over 2,
4.
4. Okay? So this whole thing is shifted up 4 units and over pi over 2 to the right. Okay? That's not grouped for some reason. All right. So I'm going to move this down a little bit to give us some room. Okay? So, got some work to do. All right? One thing here, especially with cosine, is when it's vertically shifted, I would sketch that midline. Where is the midline going to be in this case?
4.
It's going to be at 4. 1, 2, 3, 4. Okay? And I would just put in a horizontal line here, because that'll help. Alright? That's at 4. Okay? And then I'm going to need an amplitude of 2. So I'm going to have to, this graph is going to go all the way up to 6. Alright? So I also need, a pi over 2 as my starting point. Okay? So I'm going to make this pi over 2. And that means each thing on here is going to be pi over 2. Now, my starting point will be at pi over 2, 6. Okay? In fact, let me do this a different color here.
Oh, because the amplitude's 2.
Okay? Yeah, the amplitude is 2. Okay? Alright? And cosine starts at the top, so I've got to start 2 units above the midline. Okay? Now, my period is 6 pi. Alright? So, if I'm starting at pi over 2, where am I going to end?
6 pi plus pi over 2.
6 pi plus pi over 2. So that's going to be 13 pi over 2. So 1, 2, 3, 4, 5. This is going to be 13 pi over 2. And there, it's going to put me back up at the top, because this is cosine. So you're going to have to think about these x's particularly. Halfway between, I'm going to be here, and I'm going to be only at 2 instead of 4, because I'm at the bottom. Halfway in here, I'm going to be there, and halfway here, I'm going to be there. So there's my curve. Really, the most challenging part here, guys, is labeling your x-axis. Okay? But if you think about it, if it's 6 pi and I need to go up 4 steps, it's going to be 1.5 pi per. So this will be 2 pi. This will be 3.5 pi. Okay? This will be 5 pi. And then this is 6.5 pi. Alright guys, we'll see ya. Have a great day.